Sending emails should usually be an asynchronous task in web applications. This is not a problem in the development, but if you're planning to do this in production, you'll need some kind of background processing functionality. Imagine sending thousands of activation emails in few minutes. Each sending could potentially block the main application, preventing the response to new requests. To prevent this, we are going to implement Celery. Celery is an asynchronous task queue. We can split Celery in three components: the Celery client, workers, and the message broker. Client is basically any code that issues a background job. So in our case, this is the web application trying to send an email. Celery will always serialize the data it needs to execute the task, and it will put it inside of the message queue. This is the job of the message broker, which is usually Redis or RabbitMQ. Once the resources on the computer allow it, the Celery worker will take the task from the queue and execute it in the background process, therefore offloading the main application process. To implement this, we first need to install Redis on our system. This depends on your OS. In Ubuntu, I can install it like this. To check if the Redis server is running in the background, try to connect to Redis CLI. Okay, seems like it is. Inside of the virtual environment, we first need to install Celery. We also need to install the Redis package, which will integrate Python with Redis. Now we can configure Celery. Import the Celery class and declare the Celery instance next to the mail one. Celery broker URL is the configuration property we need to define because Celery needs to know which message broker to use. This is the default port of the Redis server. If you configured it differently, change it here. I'll also define another custom configuration option. This will serve as a switch so that we can have the possibility of sending emails like we did before without Celery. This is useful because we don't want to always start up Celery if we are still in the development. Now we need to initialize the Celery with our application, but we have to create this init method ourselves. Let's call it initCelery. The method will take in the app instance. We can take the broker URL from it and save it inside of the Celery instance configuration. Notice that this Celery instance is the global instance we defined up here. Then we'll define the context task class. This will extend the Celery task class which Celery uses in the process of executing background jobs. Whenever Celery tries to run a task, we are saying that it should do so inside of the application context. Remember that the point of Celery is to run tasks in the background, which means that these tasks won't have the access to the application context. This will make sure that every task has all of the needed information from the application that started it. We can achieve this by overriding the Celery task with our own context task implementation. Now we can use this method inside of the application factory. This will initialize the Celery instance with the message broker and provide the current application context to each task. We can now use this Celery instance to act as a client. Inside of the emails module sendMail method, I will check if the send mails with Celery option is true. This can be taken from the current app instance. If it is, we'll send emails with Celery. Otherwise, do it the old way. To create the Celery task, we need to first import the Celery instance. Creating a task is simple. You just decorate the method with the Celery task decorator. This method will take in the content it needs to create and send an email. This is the same code, but the difference is this one is inside of the Celery task. You may be wondering, why didn't I just create the message here and then send the message itself to the task? This is actually the reason I created this createMessage method, because I want to construct the message itself inside of the task. Whenever you send something to the task, this data will need to be serialized in JSON. JSON is a simple data structure, so if you send something like this complex message class, you will almost certainly get a lot of errors. However, this content dictionary is not complicated at all. When Celery worker decides to execute this task, the render template method will create a template using the serialized data from the content dictionary. These methods will not usually work without the application context, but we solved that problem inside of the initCelery method. Now we can just use the delay method on the task. This will send the task to the Celery message queue. There is still one more thing we need to fix inside of the authentication blueprint. Remember that these inject methods will execute whenever we use the render template method. Since we are using this method inside of the create message, the Celery task will try to access this current user proxy from the request context. This will result in an error. To prevent this, let's check if the request context exists. If it does, we will return the current user, but if it doesn't, the current user in the template can just be an empty string. This hasRequestContext method needs to be imported from the Flask package, so let's do that. I want to start Celery right from the setup module. To achieve this, I need to import the Celery instance. Set the Email Celery option to true inside of the application configuration. Okay, now the only thing left to do is to start Celery. For this, you will need to open another terminal and activate the virtual environment. This is the command that we are going to use. Celery will look inside of the setup module for the Celery instance we created. We want to create a worker that will execute the task, and we only want to log the basic information about the task execution. The Celery is now started, so let's go to the application. I'll try to register as a new user. Seems like I got the email inside of the Mailhawk inbox, which is a good sign. Check out the log of the Celery process in the terminal. This is when the email task was received, and here we can see when the task got successfully executed. And that's it, we are done with this application prototype. You can download the seed file from the exercise files to test out the application. I created this script for populating the database with some random gigs and users. Put the file inside of the app directory. To use it, we first need to import it inside of the setup module. Then we can pass it to the context of the Flask shell. The only requirement for this program is the Faker package, so let's install it. We pass the method itself to the Flask shell. So let's start it up and run the seeddb method. Once you do that, you can see that a lot of gigs and users are present on the site. The relationships between them are random, but they look real enough for testing purposes. Thank you for going through this course. If you have any questions about any part of this application, you can ask them in the course's discussion.